In the previous video in this playlist, we looked at comparing two means. We used an equal variance and an unequal variance t-test. One of the assumptions for the use of those tests, though, is that our subjects are totally independent of each other. But what if they are not? Then we have to use a paired t-test. I've opened Microsoft Excel and we see our data set. First of all, immediately this data does not conform to our concept of tidy data, in as much as I have a single numerical variable that is a ratio type variable, but I have two columns of that exact same variable. And we see in the first row we have before and after. So what we're imagining here is a research study with a study design where we measure this ratio type numerical variable in each subject. We then have an intervention, and then we measure that same variable after the intervention, so that I have pairs of values. So for each one of my rows here, I have a pair of values. Each row is still a single subject. These subjects are still independent of each other, but I have pairs of values for the exact same variable, both before and after. And so this is a common case for the use of a paired sample t-test. Other cases might be where I have homozygotic twins. There we would also consider doing a paired sample t-test because the values really are not independent of each other. They are dependent. Here though we have a quintessential example where we have pairs of values for each subject where we take this same variable. Let's imagine that this would be blood pressure. Both of these columns measure blood pressure. It is just before and after an intervention. So clearly my two sets of values here are dependent on each other. Clearly each one of the pairs come from the same subject, and the value before and after the intervention is determined by the physiology, etc. of that subject, and these two values are not independent of each other. So first of all, we are always going to copy our first data. This is the raw data. Let's go down. I'm going to call mine just data. That is my data set. I'm going to create a new sheet. Let's call this first sheet copy. And all I'm going to do now, I'm going to make a copy of all of this data. So I'm in cell A1, I'm going to hold down Shift and Command or Shift and Control. While holding those keys down, I'm hitting the right arrow key. And while still holding those down, now I'm hitting the down arrow key. And now I'm going to hit Command C or Control C to copy. And I see the marching ants. And I can go to my new sheet now. And I'm going to go to cell A1. And I'm going to do that little drop down next to the paste button, and I'm going to say paste values. And that is very good. I'm just going to click in any of these cells, and as before, we're going to go to insert, and we're going to change the data into a table. Immediately, my table has headers. I want to select that button because in the first row, I do have my variable names, and I'm going to click OK. Do understand though that in both columns here, the same variable. It's blood pressure or glucose or whatever the case might be. Now that I have a table though, let's create a brand new variable, something that we haven't done before. So I'm going to click in cell C1 as long as I am contiguous with the table that already exists. So I don't want to put something in column D. I want to put it right next door to my table, and I'm going to call this new variable difference. And as soon as I hit return or enter, you'll see that the table has now grown. Microsoft Excel understands that I'm just extending this table, and I have to have that these columns are contiguous, otherwise that's not going to happen. And let's think about the difference before and after the intervention. And let's create our own little formula. And remember, all formulas start with an equal symbol. So I'm in cell C2 here for the first subject in my data set. I'm going to type equal. Then I'm going to click on the before button, the before value right there, 33.5. And then I'm going to hit the minus key, and then I'm going to click on after. So I'm creating a little formula that takes the before value and subtracts from it the after value. So it's before minus after. And as soon as I hit return or enter, because this is a table, Microsoft Excel is going to do that for all the subjects, all the rows in my data set. And so I have a brand new I've got a brand new variable here. It's called difference, and as the name implies, it is the difference between what that variable value was before the intervention and after the intervention, that difference. So once again, we're going to create a new sheet. I'm going to call my new sheet, I'm going to call it paired t-test. And I know in the sheet I want to do a paired sample t-test. So let's go back to copy. I'm going to go to cell A1, hold down Shift and Command or Shift and Control, right arrow, and then down arrow, and then Command or Control C to copy. I see the marching ants, they go around all of my data. I'm going to go to paired t-test, and I'm in cell A1, and I'm just going to do the drop down next to the paste button and say paste values. And there we can see all the values. Once again, I'll increase the screen size. There we go. Again, let's change this into a table just in case. We're not going to use it here, but it just helps so much if your data is in a table. So I'm going to go to insert, third button across this table. I'm going to hit table. I'm selecting my table as headers because I do have the variable names before, after, and difference in the first row. And there we go. It's all in a table. Irrespective of the type of data analysis that I want to do, I always want to start with summary statistics. That is so important. And if you've watched the previous videos in this playlist, you know how to do summary statistics. Let's do that. I'm going to do that for before and for after. So I'm going to go to data. I'm going to go to data analysis, and I'm going to choose descriptive statistics. On the first button, I'm going to click on the selection button there for my input range. I'm going to go to before, Shift Command or Shift Control keys, hold those down, hit the down arrow key. All the values are selected, and I'll expand that. I do have labels in the first row. I want the output to be placed somewhere, so let's click on that selector button. Let's put it in cell E1. That's a great spot for me. And I do have summary statistics selected. I'm going to click OK, and there's my summary statistics. I can click in between the E and the F for the column names right at the top. See my pointer change. I'm going to double click there, and that just expands the columns such that I can see everything that's written inside of these cells. And there we have, for the before values, a mean, a standard error, a median, a mode, a standard deviation, a sample variance, kurtosis, skewness, range, minimum, maximum, sum, and count. Irrespective of the statistical test that you're going to do, always start with summary statistics. When you do statistics, it's so important to do this step. You learn so much about your data by doing summary statistics. Let's quickly do this for the after variable as well. Data analysis, descriptive statistics. I'm going to hit the selector button. I'm going to go to after, Shift Command or Shift Control down arrow. I expand my selector button again. I do have labels in the first row. That's great. Let's select the output range. I'm going to put that in H1. That looks like a great spot to me. Summary statistics are selected, and there we go. I'm going to just select any cell and then go up between H and I, double click there, and everything expands nicely. And we can see it looks as if this intervention led to a decrease in the sample mean. So what do we do with this information? Well, think about our study design here. We have a claim that the intervention is going to change the mean for this variable in the population. So under a null hypothesis, we would say that this difference in mean would be 0. That the intervention has no effect on the population mean for this variable. Remember, my hypotheses are always about population parameters. So I go out and I, at random, just select some subjects from this population. I measure the variable before and after the intervention, and I can look at these two sample means. Remember, a sample mean is a good estimate of the population mean. In other words, it's an unbiased estimator. And I see that this mean has gone down. Now you can also do that for the difference column, and that would be really the one that we're interested in here. So let's take the time and do that one as well. So I'm going to go to data analysis, descriptive statistics. I'll go over this quickly. Select this column, first column, Shift Control down arrow, everything is selected. I can unfold everything again. I do have labels in the first row. Let's this time put it here, right there in column K1. That'd be great for me. Summary statistics are selected. There we go. I'm going to double click between K and L, and there we see the mean difference is 4.189. Now, under the null hypothesis, I said that there should be no difference in the mean. So before minus after should give me a 0. And a difference of 4 seems to be quite big. Now, is this significant? Is this statistically significant? Now, what I can use is a paired sample t-test. Let's have a look at that. I'm going to click on data analysis, and now I'm going to go right down and see there I have t-test paired to sample for means. That's the one I want. I don't need the one that is equal variance, unequal variance. That is comparing two means between two groups of individuals, and they're independent of each other. These two sets of values are dependent on each other. So the paired to sample test is what I want. I'm going to click OK, and now it's going to ask me for these two sets of values. So I'm going to click in the selection with the selection button there. I'm going to go to before and select the whole column. That's great. I'm going to go to variable to range, selection button. I'm going to click in after, and that's cell B1, Shift Control or Shift Command down arrow, so that I select all the values in that column. I do have labels in the first row, so I want to select that. I'm choosing an alpha value. That is my type 1 error rate, my willingness to reject the null hypothesis even though it's true. And let's put our solutions, let's put them right here. Let's put them in E17. That is a good spot for me. And let's click on OK. And there we go. All the analysis have been done for us. We can see the mean before was 30.5 and after was 26.3. We can see that the variances, and we can see we had 57 subjects. We see a degrees of freedom there of 56. Very easy to calculate that degrees of freedom. It's just one less than the sample size. And since we had 57 subjects, we have 56 degrees of freedom. And there we see our t-statistic. It is rather large. We are saying that our t-statistic is 3.4672 standard errors away from 0. The t-statistic here is centered around 0. And so for us to find this t-statistic, it will really be in those zones of rejection, in those improbable t-values, intervals of t-values that we could find given that the null hypothesis is true. And if we look down here, our critical t-value on 56 degrees of freedom is 2.003. So with a two-tailed alternative hypothesis, we will have critical values both on the upper tail and lower tail. So there'll be positive 2.00 and at negative 2.00. And look at our t-statistic at 3.467. That is beyond the critical values, in the zones of rejection. And so we will say there's enough evidence in the data at the 5% level of significance to show that the intervention makes a difference. And here we can see that the intervention actually lowered the mean of this variable. So we could then state that the intervention seems to lower the value of this variable in the population. So do remember, we use the paired sample t-test when we have values that are dependent on each other. The same exact numerical variable measured twice. We have pairs of values for each subject. So as opposed to the equal and unequal variance t-test where we are concerned about the ratio of the two variances, here we're not concerned with that at all. We're just concentrating on this idea of the difference between the two means. Very easy to do here in Excel, and we still have a two-tailed alternative hypothesis that this difference is not 0. And so we look at the t-statistic and we look at the critical values for that two-tailed test. And we do remember that we have it at the positive end, the upper tail, and at the lower tail, those critical values, even though Excel only gives us the positive 2.00 here. We do also consider the negative 2.0 on the lower tail, but clearly our t-statistic is beyond those two values, and we reject the null hypothesis.